Hi guys, I hope you watched our little intro video just to kind of get your feet wet about what we're going to be talking about here. If you haven't already gotten your folded note ready so that you've folded it like this and you've cut the little flaps so that we can write our notes in there, go ahead and do that. I've already done mine, and in fact I've already filled out my notes, so I'm going to grab that one and work from that one. So let me get rid of this one. And here's my other one. All right, now I have some really good news about these properties. You are, I'm sure, very aware of these properties. Our goal today is just to help you match up the name of the property with an example of the property. And you have seen these before, I know you have. So our first property that we're going to talk about is commutative property. And there's a commutative property for multiplication, and there's a commutative property for addition. And the only thing that's different about them is when we talk about commutative for multiplication, they're multiplication problems. And when we're talking about commutative for addition, they're addition problems. Otherwise, they're really the same. So you can see my beautiful artwork here. I've drawn a bicycle up here to help myself remember that commutative means that we change the order of the number. And here's my example then. So my definition, first of all, for commutative property of multiplication is that you can change the order of the factors, the two numbers that we multiply together, without changing the product, the answer of a multiplication problem. So you can see here that 6 times 4 would give me the answer 24, and then 4 times 6 would still give me the answer 24, even though I flipped the numbers around, the order around. So when we talk about commutative, we're talking about order. Well, you might guess that the commutative property of addition is very similar, except that we're adding instead. So the commutative property of addition is you can change the order of the addends, the numbers you're adding together, without changing the sum, the answer to an addition problem. Now, of course, division and subtraction don't work this way, but multiplication and addition do. They're commutative. We can switch the numbers around. We can change the order without changing the answers. All right, if you need to pause the video to get those definitions and examples written down, go ahead and do that now. But I'm going to go ahead and go on to the next property that we need, and those are called associative properties. So just very similar to the commutative property, there's an associative property of multiplication and an associative property of addition, and they're exactly the same except that the one for multiplication involves factors and the one for addition involves addends. Now again, my beautiful stick figures, I drew 2 little people holding hands because when we talk about the associative property, we're going to talk about grouping. So commutative was order, associative is grouping. And you'll see what I mean here. So the definition of the associative property is that you can change the grouping of the factors without changing the product. Now what do we mean by grouping? It just means that which 2 numbers in a string of numbers of 3 would we do first. So you can see here that I have 3 times 2, and because it's in parentheses, I would be doing that problem first, and then multiplying that answer times 4. Now over here, I've changed it up a little bit. Over here, I've got the same 3 numbers, but now I'm going to multiply the 2 times 4 together first, and then multiply in the 3. But we'll still get the same answer. Over here, if we did 3 times 2, we see that that answer would be 6, and then 6 times 4 is 24. Over here, if we did 2 times 4 first, that would be 8, and then 8 times 3, still 24. So what we're saying here is that grouping doesn't matter. It doesn't matter if I do 3 times 2 first, and then multiply by 4, or 2 times 4 first, and then multiply by 3. Of course, addition is very similar. The associative property of addition is that you can change the grouping of the addends without changing the sum. And so you can see my example there. 3 plus 2 first, then add 1 is going to be the same answer as 2 plus 1, and then add 3. So 3 plus 2 is 5, plus 1 is 6, or 2 plus 1 is 3, plus 3 is 6. So no matter which way I do those problems, I get the same answer. Doesn't matter how I group them, how I associate them. Over here, these two guys are best friends, and then we multiply this one in, and over here the best friends have changed, and then we multiply in our third friend. Again, if you need to pause the video to get these definitions and examples down, go ahead and do that. But I'm going to go on to the identity properties. So I've drawn this beautiful mirror here to remind myself about the identity properties. Now the identity property of multiplication says that if I have a number and I multiply it by 1, my answer will be that number. In other words, 7 times 1 is 7. And you knew that. You just need to know now, but that's called the identity property of multiplication. 7 times 1 is 7. And then over here, the identity property of addition, well, that's not going to be 1, it's going to be 0 instead. So 5 plus 0 is 5. And this definition then is a number added to 0 is that number. So the identity for addition is 0, and the identity for multiplication is 1. But those are called the identity properties. Again, if you need to pause the video to get those definitions and examples in, then go ahead and do that. After you have your notes filled out, there's a summary video to watch, so go ahead and do that, and then we'll be taking some notes over the distributive property here in just a little bit. Remember to get your notes filled out and bring those to class so that you can do the activities that we're going to be doing in class to follow up on this lesson. Thanks, guys. See you in class.